right, hello, welcome back. Long time no see. Had that long fall break and haven't had any videos recently. Today's Wednesday. I plan on uploading this evening. We're gonna do two lessons in one, but one lesson 3-4 is only 2 slides, so it won't take long at all. And then the other lesson is only 6 slides, so only 8 slides total today. Where we're going with this, before I jump in, we're getting ready to, this is going to wrap up Unit 3. Now, we already had a Unit 3 test. That was the first half of Unit 3. These last 3 lessons will cover the second half of Unit 3. We did the first 2 back before fall break. So, technically, the sections covered on this are going to be 3-4, which we're going to do today in 2 screens, 3-5. There is no 3-6, and then we did 3-7, 3-5 and 3-7 we did before fall break, and then the bulk of this lesson today is going to be 3-8, and then we'll have like a nice juicy test on it. For you online people, it'll be next week. It'll probably be Tuesday, Wednesday of next week, and the review, I'm going to post this lesson with the homework tonight, Wednesday, and then on Friday morning, probably bright and early, I think the review and even the answer key to the review, that'll be available Friday morning. Mr. Crabtree sent out a link to his 2 Google Meets. He's going to Google Meet Friday at 2:15 and Monday at 2:15 if you want help on questions. So you'll get that review. You'll be able to access it Friday morning, look it over. If you want to come to the Friday afternoon Google Meet for questions, or if you want to have the weekend to look at the review and then come to the Monday Google Meet for some questions, please do that. 2:15. The link is in the top of the My Google Classroom, so it's there and ready to go. So that's how the test is. Like I said, the main thing is it'll be probably available on Tuesday and Wednesday of next week. All right. Okay, so let's jump right in. Today, what's going to go on? We're going to be talking a bunch about parallel and perpendicular lines, their slopes, the equations of lines. So the main thing by the end of this little combo lesson today is you should be able to determine if 2 lines are parallel or perpendicular. You should be able to write equations of lines and make them parallel or perpendicular to another line and stuff like that. So that's what we're going to do, and we're going to jump right into it by making sure you understand officially now what the word perpendicular is. It's 13 letters long, so no way I'm going to write that again, especially when we have this cool symbol that represents perpendicular. It's an upside down capital T, because as you know, a capital T would be right angles, and that's what perpendicular means. It means they intersect each other at right angles, which are 90 degrees, and a capital T would do that. But we don't want to use a capital T to mean perpendicular, so we just flipped it upside down. So here's your symbol for perpendicular. It's an upside down capital T. And whenever you see that, that means the things are hitting each other or intersecting at right angles. All right. Now, we're going to have these 3 theorems, starting with this one and then 2 on the next slide. They might seem like they're common sense, but we just need to make sure you understand them. But theorem, and again, THM stands for theorem, means it's a proven fact. Theorem 3.8 says if 2 lines are parallel to the same line, then they have to be parallel to each other. Meaning, if I have line A and B parallel to each other, and they are because they each have a red arrowhead, and then I have lines B and C parallel to each other, which they are because they both have double arrowheads. So A is parallel to B, and B is parallel to C. What this theorem is saying that for that to be, if that was true, then A would also have to be parallel to line C as well. Even though I didn't tell you that, I just told you A was parallel to B, and B is parallel to C. According to this theorem, they all 3 have to be parallel. And some of y'all are saying, well, duh, Mr. Metcalf. And I'm like I told you, some of these are just kind of common sense. All right, moving on. I'm going to pretend like you had a chance to copy it. And if you didn't, pause. We're moving on. 2 more theorems about being parallel and perpendicular. This one says, and both of these have to say in a plane, because these two actually would not work out here in 3D space. They would not work necessarily. They could, but they wouldn't be guaranteed to. But in a plane or on a flat surface, these are definitely going to work. So in a plane, if two lines are perpendicular to the same line, then they have to be parallel to each other. So just so you see my diagram here, I've got a cursive M as in Metcalf and a cursive N line as in Nancy. And then this is probably the hardest one. That's a cursive T as in Tango. And Tango is he's perpendicular to M, and he's perpendicular to N. And if he is, the only way that's possible is if M and N are parallel to each other. All right. So T's parallel to M. I'm sorry, perpendicular to M. T's perpendicular to N. So that means M and N have to be parallel. Again, maybe to you that's common sense, but we're just making sure you understand. This one is almost the converse of this one. This one says, also again in a plane, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other one. So say you got two parallel lines. I'll use this picture again. Say M and N, I know they're parallel, and say I know that T is perpendicular to M. Well, if he's perpendicular to M and N are parallel to each other, then T would also have to be perpendicular to N also. All right. So again, maybe it's common sense to you and you're like, Mr. Metcalf, I already knew that. It would have to be true. Then that's okay. Good job. Now, will these things be on the test? These, theorems about parallel and perpendicular? Not necessarily, but they're just good to know. Okay, now we'll move on to the more important part of the lesson. Okay. Uh-oh. I was supposed to do this before the lesson started. I'm sorry. Let me just calibrate the board real quick. I'll edit all this out in the final copy. Okay. Boom! Oh, a skip string already. Bam. Okay. Forgot about that one. So now we jump into, and technically that ends lesson 3-4, and now we're jumping into lesson 3-8, which you see is also slopes of parallel and perpendicular lines. So the same topic. I'm not really sure why they split this into two different lessons. But here we go. Postulate 3-4. Here's some cool things about the slopes of parallel lines, and the most important, notice the big asterisk right here, the most important thing is that the slopes of parallel lines are equal to each other. Imagine that. If this line right here is going up 3/4, and I want to be parallel to him, I better go up 3/4, right? So we would be parallel to each other. So parallel lines have to have equal slopes. Very important. And then obviously all vertical lines are parallel, right? You have vertical lines. You maybe have one way over here. Maybe you have one real close. They're always going to be parallel to each other. Same thing with horizontal lines. You have two horizontal lines. They're always parallel. Doesn't matter, where they are. They're going to be parallel. And there's just some interesting stuff about parallel lines. And again, pause it if you need to, because here's some interesting stuff about the slopes of perpendicular lines. And this is where it gets a little more tricky. The whole slopes being equal kind of makes sense for parallel lines, but now with perpendicular, some students said in the in-person classes, they said, well, are they going to be like the opposites of each other? Like maybe one of the slopes, like the slope of this guy would be positive and maybe the slope of this guy would be negative. Is that how it works? Well, kind of. That's kind of close. And then another student said, well, maybe the slopes are flipped. Maybe they're that. Well, that's close too. Matter of fact, if you put those two concepts together, that's how perpendicular slopes have to be. They have to be what we call opposite reciprocals of each other's. Very important. Look how big that asterisk is. It's even bigger than that one. So this is really important. The slopes of perpendicular lines are what's called opposite reciprocals. What does that mean? You've learned both of those words, but now we're putting them together. Reciprocal is simply when you take a fraction and you flip it. Like if I said the fraction is 1/2, the reciprocal of 1/2 would be 2 over 1. All right, see, that's what reciprocal means. You just flip the fraction. Opposite has to do with their signs, positive or negative. So if I said I have a number and it's -8, and I said, what's the opposite of -8? Then you say, of course, +8. Well, you did that back in middle school, and your teacher did lessons on that about reciprocal and opposites. I'm going to ask you to put that together. You have to do both, all right, to find perpendicular lines. So if I gave you a slope of -2 over 7, and I want to be perpendicular to him, so I need to have the opposite reciprocal. You have to do both things. You have to change the sign and flip the fraction. So the opposite reciprocal of -2 over 7, well, the opposite part, since he's negative, this guy would have to be positive. And then the reciprocal part would be, well, he's 2 over 7, so this guy would need to be 7 over 2. All right? Everybody feeling good about that? So that's opposite reciprocal. I know you can do opposites. I know you can do reciprocals, but now you need to be able to do opposite reciprocals together. All right? So another thing, and this gets an asterisk next to it because I'm not going to use this one as much because I think this is easier to take a slope and then just do the opposite reciprocal of it. Another way to determine if slopes are perpendicular is they have a product of -1. Now I hope everybody remembers that product is the fancy way to say which operation? Add, subtract, multiply, or divide. That's right, multiply. So if you take two slopes and you multiply them, product, and you get a -1, then those two slopes would be perpendicular slopes, all right? So if you look at my example of -2 over 7 and +7 over 2, if you were to multiply those, -2 times 7 would be -14, and then 7 times 2 would be +14, and guess what? When you simplify that down, of course, what do you get? You get -1, all right? Just like it says right here. So if your slopes multiplied give you a -1, then they're also perpendicular. And then the last thing is this. Any horizontal line and vertical line, they would be perpendicular. So say you got a vertical line and you got a horizontal line. It doesn't matter which ones, any vertical and any horizontal, you put them together, bam, perpendicular, right? So there we go. There's the information part of the lessons. Now let's do some math problems, shall we? And what did I do? Here's my marker. Okay, here we go. Man, I've got to apologize. Ethel has been really temperamental since we've been back from break, and I had a feeling this was going to happen. Let me just recalibrate her again. And again, you can fast forward through this part, or maybe I'll edit it out of the final version. Okay, so here we go. I'll step to the side. I'll be honest with you, in class we only did the first two, so if you want to write down number 3, you can, just for additional practice. We're gonna do these. We're gonna do the first one together because Mr. Metcalf always wants to do lessons like this. I do it, then we do it, and then at the end you do it. Yeah, that's how we like to do it in education today. So we're going to determine if these two lines, are they parallel to each other, are they perpendicular to each other, or are they neither? What would neither mean, Mr. Metcalf? Well, lines basically can interact in a couple of ways. In a plane, remember, if I say we're out in 3-dimensional space, they can do all kinds of stuff. But in a plane, they basically have 3, sometimes people get a little sketchy and say 4, but usually the 3 things are: lines can be parallel, lines can be perpendicular. That means they intersect each other, but they do it at perfect 90-degree angles. And the last one is neither. So what does neither mean? Well, it means they still hit each other and they intersect with each other. They just don't do it at perfect 90-degree angles. They just make a generic X, so to speak, instead of a perfect T. That's perpendicular. Any way else is just, they just hit each other. And that's what neither would represent. Some people throw in a fourth one, and I think this is shady, but sometimes they'll say, well, two lines could actually lie on top of each other. Well, not really. If they're on top of each other like that, they're literally the same line. So it's hard to say, but some people do. All right. So we're just going to focus on parallel, perpendicular, and neither. Now here's your cheat sheet. We just learned, so let's emphasize it again. We just learned that to be parallel, your slopes need to be equal. So I'm going to put a big equal sign next to parallel. And to be perpendicular is this sort of new concept of putting opposite and reciprocal together. That's new. Opposites aren't new. Reciprocals aren't new. But putting them together is. So if it's opposite reciprocal, then they're perpendicular. And neither, what's that, Mr. Metcalf? That's anything else. If they have any other relationship, they are neither. Anything else. So here's what we're going to do. We're going to find, for the first one, we're going to find the slope of line AB, and they provided the points for A and B. I'll do that in this pretty green color, so I'm going to kind of box them in to show they go together. And then we're also going to find the slope of CD, and then we're going to compare the slopes to see if they're either equal, opposite, reciprocal, or something else. All right? So let's do AB. Hopefully everybody remembers the slope formula. Most of the 6 classes were able to come up with it. I think actually 5 out of the 6 could remember. Somebody could remember the formula. That formula for slope is, and I'll write it right here. Slope is, and remember we use the letter M. It's the second y minus the first over the second x minus the first. All right, that's how you calculate slope if you have 2 points. So we're going to do that for AB and then for CD. So here we go. We'll start off with AB, and his slope would be, well, Mr. Metcalf, we need to label these guys, right? Well, A came first, so he's going to be my X1 and my Y1. B came second, so he'll be X2 and my Y2. And now I'm going to put the, I forgot to put a little 1 next to him. I'm going to do second y minus first upstairs. So upstairs I have -5 minus 1. And downstairs I'm going to subtract the x's. So I'm going to say -1 minus +1. And of course that would come out to be -6 over -2. And then of course a negative divided by a negative is a positive. And then 6 divided by 2, some people would just say 3. We are talking about slope, so I'm going to leave it as a fraction. And how I did that would be like, okay, both of these can be reduced down by 2. 2 goes into 6 3 times, and 2 goes into 2 1 time. So his slope is a positive 3 over 2. So now let's find CD's slope, and I'll do that in this pretty purple color. So CD's slope is, and let's relabel our coordinates, he'll be X1 and Y1, he'll be X2 and Y2. So again, we're going to subtract the y's on top, so we're going to say 1 minus 2, and down in the basement we'll say 6 minus 3. So 1 minus 2, that would be -1. 6 minus 3 would be 3, and that will not reduce down any, so that's his slope. So now we look at the first slope and the second slope, and we decide, are they parallel, perpendicular, or neither? Well, I said to be parallel, they have to be equal. They are definitely not equal. So how about opposite reciprocals? Well, they're definitely opposites, because he's positive and he's negative. So they're opposites, but they're not reciprocals, are they? No, you know that. He's 3 over 2. This guy would have to be 2 over 3, but he's 1 over 3. So they're not opposite reciprocals either. So this is a straight up neither problem. These two lines are neither parallel or perpendicular. They're something else. All right. Any questions on that? So now, in the in-person classes, I had the students do these two on their own. All right. So you need to calculate the slope of FG. I'll box those two guys in blue, and then also the slope of HJ. I'll box them in with red. And I'll pretend like you just took a few seconds to do that. Okay, let's see if you got the right answer. Oh, and once you found their slopes, you should compare them to see which one of these three it would be. So I'm going to pretend like you paused it and you did that. And let's go ahead and see if you got the answer right. Let's go back to blue for FG. We want to find FG's slope. So I'm going to say line FG. His slope would be, and again, I'm going to label my points, x1, y1, x2, y2. So upstairs, I'm going to have -1 minus double negative, our first one back from fall break, right there. Okay, hopefully nobody falls into that trap. Downstairs, we're going to subtract the x's. So we're going to say -2 minus 1. And let's take care of that double negative. Double negative means it turns into positive, positive. And -1 plus 3, that would be +2. And downstairs, -2 and -1 would make -3. So his slope is 2 over -3. Now, question came up here in class. Where does it matter where the negative sign goes on a fraction? Technically, there's 3 locations, all right? This one happens to be in the basement, and I'm just going to write this right here. It's 2 over -3. It doesn't have to be in the basement. If you don't like it in the basement, you can move it upstairs and call it -2 over 3. And then sometimes you'll even see the fraction, the negative sign in front of the fraction. So you could actually move the negative sign out front and just say negative and then 2 over 3. All 3 of those are the same thing, and they mean the same thing. It's okay. You can put the negative wherever you want it. Just don't put 2 negatives, because if you put 2 negatives, you just made it positive, and you don't want to do that because he's definitely negative. All right, so we got the first one. Let's now do the slope of HJ and compare it to that. And so we need some new coordinates again. He'll be my x1 and my y1, and he'll be my x2 and my y2. So we'll find their slope. Let's see, this is line HJ, right? So line HJ, his slope will be, subtract the y's on top, 3 minus 0. Subtract the x's on the bottom, 6 minus 5. And when you do that, you get, upstairs you get a 3. Downstairs, 6 minus 5, you get a 1. And we'll leave it like that because it's a slope. And we'll compare them. And wait a minute, I have done something wrong here. I have done something absolutely wrong. Because this is going to be a neither as well. What happened up here? -6. Oh my goodness, you all didn't say anything. Oh my God. Well, that's because you're watching a recording. You couldn't say anything. Did you see what I did up here? This one is truly neither, because you got a 2 over 3 and then a 3 over 1. So they're not equal and they're not reciprocals. This one is truly neither. But the first one, I thought something was wrong with that one. Man, how many of y'all were yelling at your screen at home? Because look what I did here. I reduced these down by 2. So let's fix that. We got to fix this real quick. When I reduced this down by 2, I said 2 goes into 6 3 times. And when I should have said 2 goes into 2 1 time. So, man, I really should edit that out. I'm probably not going to, though, so. And then when you do that, they are perpendicular to each other. Oh, my goodness. Because, look, positive, negative, 3 over 1, 1 over 3, that is absolutely perpendicular to each other. So Many apologies on that. Wow, I'm sorry. I really should fix that. Well, I kind of did. I fixed it. I'm not going to go back and redo that one. Man. So even when you go to Purdue, sometimes you make a mistake. Not often, but I just video recorded one right there. Okay, so yeah, oh man, I hope, how many of you all noticed that at home that I made that mistake? Man, raise your hand if you did. Okay, a few of you noticed it. All right. So the second one is technically the neither. The first one actually was a perpendicular. All right, and see, that's why I probably should have some cheat sheets in front of me so I wouldn't make mistakes. But I don't like to. That's not my style. So even teachers make mistakes sometimes. So instead of getting a 104 on this test, I'm going to probably get a 96 on this one. All right. Nothing wrong with that, though. And again, here's a third problem if you want to practice it at home. I have a feeling, since this one's perpendicular and this one's neither, I have a feeling this one will come out to be parallel, but I don't know that for a fact. So if you might want to try it, shoot me an email and tell me, hey, this is what I got. Is that right? I'll work it out. Maybe I'll get it right. Whew. After all that, man, even made a mistake right here on camera and stuff. After all that, man, I don't know about you, but I could use a nice little skip screen. Boom! Check that out, man. Just what the doctor ordered, a skip screen. You know, the only thing better than a skip screen is 2 skip screens. Boom! Check that out. Oh my goodness. Awesome. So let's move on. We are flying through this lesson now. Gonna give you some time to jot this down, because this is where the water hits the wheel, as old people sometimes say. This is where the action happens. What they want you to do in this problem is they want you to write the equation of a line that's parallel to this line. All right, that's a line right there. You see your y equals mx plus b situation. So we want to make an equation parallel to him, but it contains the point -1/8. All right, so it needs to have those, that it needs to be parallel to that first line, but also hit -1/8. If I said just be parallel to him, it would be super easy, right? You would just say, hey, if I want to be parallel to him, I just need the same slope. So anything that has a -3x would be parallel to him. I just would make sure I didn't use -5 on the end. I use any other number would work. But they want to be a little more specific than that. They want to be parallel to him, but they also want to go through this point. So how do you do that, Mr. Metcalf? Well, they want an equation of a line, and an equation of a line has 2 juicy ingredients. We're going to use our old best friend, y equals mx plus b. Oh my goodness, guys. Can you believe this? I am out of calibration again. All right. Let's see. How bad? It's not too bad. I'm going to try to go for it for a little longer. All right. So if I want to be parallel to him, I hope everybody can look at this and just tell me what his slope is. If you can't, I'll remind you that if the y is by itself, which it is, then the slope is the number stuck to the front of the x. So y is by itself, here's the x, so his slope is -3, and if you want, you can say -3/1. We do usually, in many instances, we like our slope to be a fraction, so you can put it over 1 if you like. And so we've got the first ingredient. The first ingredient, slope, is -3, all right? Because we want to be parallel to him. So now all we need is a y-intercept or a b, all right? So how do you find that, Mr. Metcalf? Do you just randomly guess? Some students said, hey, do we just grab that 8 and say that's the y-intercept? No, there is one instance where that would work, and that is if the first number was a 0, then the second number would be the b, but that's only going to happen. It might happen once on your homework, but it's not normally going to happen. So what you do instead is you take your new best friend, y equals mx plus b, and you fill in all the stuff you already know. All right, you know most of it. We just found out that the slope is -3, so I'm going to replace m with -3. I don't know what b is, so I'm going to leave that as a b. And now if I only had a y and an x, then I'd be in good shape. Well, guess what I've got right here? An x and a y. All right? So I'm going to replace the y and the x with the actual values that they provided to me. So I'm going to replace this y with an 8, and I'm going to replace this x with -1. And then I've created a little, I would call that a pre-algebra problem right there, a little pre-algebra problem to find out what b is. So again, you would do -3 times -1, which would be +3, plus the b, equals 8. And a lot of people can stop right there. They're like, well, there's only one number in the whole universe that you could add to 3 and get 8. Most people know what that is. If you're not thinking that way, you might just go ahead and solve it algebraically and get rid of the 3 by going -3 and -3. And of course, you would get b equals 8 minus 3, which is 5. So now you have both ingredients. You have a slope, -3. You have a y-intercept, which is 5. So you just take those and put them into the equation. So your final answer would be y equals -3x plus b, which is 5, and you're done. So this line right here would be parallel to this line right here, but it would go through -1/8. And you can graph it if you want to make sure, but it will. Now, some students said, oh, well, Mr. Metcalf, I have a shortcut. Since he was -5, all you do is make him +5, right? No, that's a coincidence. It did happen like this on this problem, but it won't normally happen like this. And here's what I mean. Like on this one, it's -7. Does that mean the answer is going to be +7? No, I would bet a lot of money that it's not going to be. This just happened to be a coincidence. So don't do that. Don't say, oh, I just make it the opposite of what he... No, that doesn't work. It did in this one, but not usually. So now is where I would pretend like you all are pausing it and you all are doing the exact same thing that we did here, but with this problem. I will give you one hint, because I'm looking at this guy's slope and there's not a big juicy number in front of the x. And that's because the slope is, that's right, a ghost -1. Woo! Just in time for Halloween. So his slope is -1, and again, I want to be parallel to him, therefore my slope needs to be -1. So there's the ingredient number 1. The slope is -1. Now you have to do that y equals mx plus b thing to find the b. And let's pretend like you just paused and did that. All right, here's what you would do. You take y equals mx plus b. You fill in all the stuff you know. You know the slope's -1. You don't know what b is, so you just put plus b. And now you just need an x and a y. And look what they provided, an x and a y. So I'm going to replace y with 3. I'm going to replace x with -5. And solve that for b. Well, -1 times -5, that's 5. Plus b equals 3. So to find out what b is, I got to get rid of the 5. So I say -5 and -5. And I get b equals 3 minus 5, which is -2. So I've got my two ingredients. I got my slope. I got my b. I just put them into the magical formula, and my final answer is, oh my goodness, I am out of calibration. Y equals -1x minus 2. And as promised, it didn't end up being the opposite of -7. It's -2. Now, on a multiple choice test, those answers are usually in simplest form. And if you look at this, there is one thing that is written that is not necessary. It's perfectly correct, but it's not necessary, and that's the ghost 1, right? Or in this case, ghost -1. So on a multiple choice test, you would probably see it written this way. Y equals just -x minus 2. They mean the same thing. They're both correct. One is just a little more simplified. All right, any questions on that? Okay, let's move on. And at this point, I'm going to calibrate one more time. Hopefully hopefully just one more time, because it's really hard to write when these things are not calibrated, guys. I'm not going to lie to you. And hopefully that'll do it. Now, some of y'all are saying, Mr. Metcalf, these are two more of the exact same problems we just did. Almost. There's one molecule of difference on these, and that is, see if you can pick it out. This time, they want us to be perpendicular to this line and pass through a point. So, you have to change one thing, and that's it. Instead of just saying, oh, well, his slope is 1 over 5, so I want my slope. No, you don't want to be parallel to him. You want to be perpendicular to him. So instead of using our slope as 1 over 5, I'm going to say the perpendicular slope to 1 over 5 would be, remember, opposite reciprocal. So he's positive, we need to be negative. He's 1 over 5, we need to be 5 over 1. All right. Now, a lot of people are saying, hey, Mr. Metcalf, negative 5 over 1, that's really just negative 5, right? Can I use negative 5? Yes, for the math purposes, please just use negative 5. And even with the answer, most people would not put that over 1, though it is a slope. And a lot of people are like Mr. Metcalf and say, hey, slopes, it's nicer when they're fractions, so you have your rise and your run. But it's not necessary, so it might be eliminated. So if you want to just use negative 5 as your perpendicular slope, that's fine. But there's ingredient number 1. And then the rest of the problem is just like we did on the other two. You use that y equals mx plus b. So let's go ahead and do that. I'm going to pretend like you paused and you went ahead and worked on it. And now we're just going to fill in all the information we know. Now please be careful. Do not use the 1 over 5 for the slope. Use the negative 5 or negative 5 over 1. So I'm going to use the negative 5 because we're going to do a little bit of math here. So let's just go negative 5. I don't know what b is yet. And now I just need an x and a y, and look what they provided, an x and a y. Now some of my students got kind of freaked out the other day because this b is going to be quite large, and the reason is because look at that, we got a 15 for x, and you know we're getting ready to multiply that by negative 5. So you could get a pretty big number in this situation. And then our y is negative 4. So we're just going to go ahead and pre-algebra that on out. Negative 5 times 15, that's going to be negative 75 plus the b equals negative 4. So I got to get rid of that 75. So I add 75 to both sides. And they cancel out. So b equals negative 4 plus 75, that would be 71. So now there's the second ingredient, and that's all you need. You just need two ingredients, a slope and a b. And I put them into the magic formula, so it's going to be y equals negative 5x plus 71. So this equation right here, this line, would be perpendicular to that line and go through this point. Amazing stuff, right? Awesome. Here's one more for you to do. Just remember, it's also a perpendicular, so don't use negative 3 as your slope. Use the opposite reciprocal of it as your slope. And then there's your point. The rest of the procedure is the same. Let's move on to the last concept. And that is, again, determining if the lines are parallel or perpendicular, but they don't give us points and want us to find the slope. They give us equations of lines that are not in the format we like. Most people like slope-intercept form because slope-intercept form, it's easy to graph. You can see the slope right away. These are not in those forms. Some of y'all might recognize this guy. He's in point-slope form. And therefore, 2/3 is your slope. So, you know his slope already. That's the slope position in point slope form. I'm going to just show you a way to make sure. But what we're going to do is we're going to convert everybody to y equals mx plus b form. And then we're just going to compare their slopes to see if they're parallel, perpendicular, or neither. So we'll just go ahead and we'll do the first one together. So hopefully everybody's got it written down. First thing you do is the distributive property. If you don't recognize right off the bat that his slope is going to be 2/3, then do the, work it out. If you know that, then just say, hey, his slope's 2/3. I'm going to move on to the next one. If you don't, here you go. 2/3 times x is just, well, let's see, I need some scrap work. I'm going to write it right here. 2/3 x. And then 2/3 times the minus 6. Hey, Mr. Metcalf, some people know what 2/3 of 6 is, or negative 6. If you don't, put him over 1. Multiply your tops. 2 times negative 6 is negative 12. Multiply your bottoms. 3 times 1 is 3. And then a lot of people know that's just going to turn into a big fat minus 4. So this is 2/3 x minus 4. But I've been neglecting the left-hand side. It's still y plus 2. So technically, I know the slope already. But if you want to go ahead and follow through the procedure to make it look like this, you get rid of that plus 2 by saying minus 2 minus 2. And of course, he would cancel out. So your final slope-intercept form would be y equals 2/3 x minus 6. So his slope is 2/3. Now I got to find his slope and compare them. All right. So in this one, the 3x is in the wrong spot. So I'm going to go minus 3x minus 3x. Remember, our goal is to make it look like this. We want the y all by itself over here on the left, everybody else on the right. So I'm getting rid of the 3x because he's on the wrong side. So that cancels out, and I'm left with 2y equals, I'm going to put the x first because x is first, constant second. So I'm going to say negative 3x plus 8. And then all I have to do now is divide off this 2. So I divide by 2, divide this side by 2, and I would end up with y equals negative 3 over 2 x plus, what's 8 divided by 2? That's simply 4. So his slope is negative 3 over 2. These two are obviously not the same, so they're not parallel, but are they this weird opposite reciprocal thing? Well, they're opposites because he's positive and he's negative, so there's that. Are they reciprocals? 2 over 3, 3 over 2. Absolutely. These two lines are perpendicular. Okay. You can do the same with this one. I'll just go ahead and do it because we're almost done. It's the last problem, last screen. Again, you've got two that are almost in the in the correct format, just need to move maybe one thing. And let's see, I guess I can block this off somehow. Let's sort of give ourselves some separation here. Let's get that out of the way. And yeah, okay. So we need to make this into y equals mx plus b form. The only thing in the wrong spot is this minus 4. So let's go plus 4 and plus 4. So that cancels out. So you have y equals negative 2x plus 4. So his slope is negative 2, right? Now I just got to find out what his slope is. And some of y'all, my speed demons, probably already know what his slope is. But I got to get rid of this 2x. So I go minus 2x, and I end up with him getting canceled out. So I have y equals, again, the x term should come first. So we'll go minus 2x plus 9. And therefore his slope is negative 2. His slope was negative 2. That is equal to each other. So these two lines are parallel. Parallel, not 11, but parallel. All right, so there should be a worksheet ready to loaded up, ready to go for you. Remember, work on that the next couple of days. And then Friday, the review should be on Google Classroom first thing, 8 o'clock in the morning with the answers. So look at that and either come, if you have questions, either come to the Friday afternoon Google Meet for you early birds who get up Friday morning and do the review. Or if you're not an early bird, come Monday. You've had the whole weekend then to look at the review. come Monday afternoon to his Google Meet, and that code is on Google Classroom. The test should be available again. It'll be in Performance Matters. The test should be available on Tuesday and Wednesday. Hope you have a great day. I'll see you soon. Bye.